Yeah, they can dissolve in water. What about this model explains why they typically do dissolve in water? Are these little green and purple things atoms? No, because it's an ionic solid, those would be what? Ions. And ions have a what? A charge. Because water's polar, the charges of the ions would be attracted to the water. I think that was one of your free response questions on the review. They wanted one lithium, what's it, chloride? They wanted one lithium chloride formula unit. So here's a lithium ion dissolved, here's a chloride ion dissolved. The lithium is positive, so the oxygen side of water would be surrounding this, whereas over here chloride's negative, so the hydrogen side of water would be surrounding. So it's all charges, opposite charges attract. Good. Group 4, what's another property of ionic solids?
So they're solid state, they're pore conductive, and they're dissolved.
Right, yeah, so you hook a conductivity meter or battery up to a solid. There's nothing moving from point A to B in there. Yeah, there's charges, but they're all lined up in nice neat rows, can't move, it's not going to conduct electricity. If you dissolve it though, those ions are moving, so an electrical current on one side would pass through with those ions and pop out the other side, and it would complete the circuit. What state of matter would an ionic solid be a conductor? Besides aqueous? Yeah, the liquid. So molten salt, because you do have moving ions, they would conduct electricity. So aqueous, liquid or molten salt. You don't really see gaseous salts very often, but yeah, I guess you'd have ions moving, so I guess that would conduct electricity as well. That would be hot though, I would want it to be nowhere near that. Okay, group 5. What's a property of molecular solids or covalent molecular solids? They're not rigid. Are they malleable? So you hit water with a hammer and it bends? No? Okay. What holds those molecular solids together? Like up here you have the sea of electrons, here you have positive and negative ions attracting. Good, intermolecular forces, which is a huge topic on the AP exam. Just to review, what are some of those intermolecular forces? I just talked about it the other day in first year chemistry. The strongest one being probably no wonder dispersion's the weakest because they disperse. Yeah, so hydrogen dipole would be a pretty positive H and negative electrons. So yeah, that's going to be the strong, well, typically first year chemistry, strongest intermolecular force. Dipole would be partial negative, partial positive. According to Coulomb's law, that would be a good attraction. But a partial positive and dots, full negative, would be a better charge. So that's why hydrogen bonding would be the strongest. But probably ion dipole might even be better because an ion is a real charge. Could be a +2, could be a +3. We typically don't talk about ion dipole attractions first year chemistry. To be honest, if we're in a covalent compound molecular solid unit, we're not talking about ions. So yeah, up here in the ionic solids, you would have ion dipole attractions dissolving in water. But for molecular solids, it's really hydrogen bonding, hydrogen bonding, dipole, and then dispersion. Good. Questions? So when you melt a molecular solid, are you breaking the bonds or breaking the intermolecular forces? Right, the intermolecular forces. Because when you melt water, are you splitting the H's and O's apart? No, that's electrolysis. It takes a lot of electrical energy to separate H's and O's. Whereas here, you're just breaking the sticky attractions between the negative O and the positive H. Good. Group 6. What's another property of covalent compounds and molecular solids? which type would not be soluble in water? Okay, yeah, because organic compounds are polar or non-polar? They're often non-polar, yeah, so non-polar molecular solids would have no charges, water would not be strongly attracted to it. The opposite of non-polar would be polar, yeah, you have polar molecular solids such as sugar. Yeah, sugar dissolves in water all the time, so it would have to be a polar molecular solid because now these little molecules would have a partial positive, a partial negative. What's going to happen if you toss a molecular solid in water? A polar molecular solid in water dissolves, and then you check its conductivity. Put sugar in water, check its conductivity. It would be conductor, non-conductor, non-conductor. Because sure, there's partial polar charges here, but there's really no real charges. Nothing there to carry the charges. Whereas up here, you have positive and negative ions. They're allowing the electricity to flow. Sugar water would not conduct electricity. And then finally, this year we talked about these covalent network solids. They're going to be a lot stronger. They're held together with these covalent bonds. So for example, a solid piece of carbon. There are no carbon molecules in there. It's just carbon connected to carbon, connected to carbon, connected to carbon. So that's why these covalent network solids are generally solid at room temperature. Think diamond, graphite, charcoal, silicon, computer chips. Whereas most molecular solids, for the most part, they're what state of matter at room temperature? Because they only have these like sticky intermolecular forces, not very strong. They're probably liquids like water at room temperature or even gases. If they only have dispersion forces or maybe some dipole-dipole forces, they're probably gases at room temperature. Whereas if they're stickier like water because of hydrogen bonding, yeah, they can be liquids at room temperature. Wax, that's an organic molecule. It only has C's and H's. You guys did the combustion lab with wax. I think it's C25, double it 50, add 2, 1 extra H on either end, so H52. Yeah, that's a solid at room temperature. Quick conversation, why is that molecular solid? C25, H52. What's so special about that would be a solid at room temperature? Quick conversation.